This is my chapter 20 reassessment video. The question goes as follows. A long straight wire carrying a steady current is in the plane of a circular loop of wire. A. If the loop is moved closer to the wire, what direction does the induced current in the loop flow? And B. At one instant, the induced EMF in the loop is 3.5 millivolts. What is the rate of change of the magnetic flux through the loop at that instant in Webers per second? So the expression for magnetic field due to the wire is this equation right here. This is our magnetic permeability. This is our current, and R is the distance from the center of the loop to the point. So we're going to use the second equation because according to Faraday's law, an electromotive force is induced in the current and is proportional to the rate of change for the electric flux. So as you can see, we're going to use the EMF rate of change over DC, the change in time. So according to the right-hand rule, for the way it's going to go, we point our thumb in the direction of the current. So the current is going this way. So this is how it's going to go. So therefore, as the loop comes closer to the wire, the magnetic field increases, and the induced current in the loop generates a magnetic field opposite to the magnetic field. So the current is going to go in the counterclockwise direction. Yeah, it's going to go counterclockwise. So that's the way that it goes. And so plugging in Faraday's law, we're going to use this expression right here, magnitude of the EMF. So we're going to do the rate of change in flux over the change in time, and that gives us our 3.5 millivolts. And then since it's millivolts, we do 3.5 times 10 to the negative 3. And then to convert that to Webers per second, we get 0.0035 Webers per second. So to answer the questions, A says if the loop is moved closer to the wire, what direction does induced current in the loop flow? It was counterclockwise. And it's going to answer B, at what instant the induced EMF in the loop is 3.5 millivolts. And we're going to answer in Webers per second. It was 0.0035 Webers per second.